In this lesson, we will start solving equations. Now, the first thing we want to talk about is what does it mean to solve? So when I see this word solve, for me, that's asking for what is the value or number that makes this true. Now, for equations that we're going to work with, there is only one number that's going to make it true. So when we take and we look at something like 3n equals 12, this is a situation where we know that this is the same as 3 times n equals 12. Or another way that we can think about this is to actually turn it back a little bit to when we first started learning about multiplication, and you'd often see it written like this. And your job was to fill in that box. Now, when I look at this equation, I'm asking myself, what do I need to multiply 3 by to get 12? And I know that that number is 4. So I have actually solved this here and decided that n is equal to 4 by using what we call inspection or by trial and error. So these are the first ways that we're going to learn to solve an equation. And then we will be building on this in future lessons. So we're going to do the first example out of your notes, and we're going to do it both by trial and by inspection, and see the differences and some of the strengths of each of them. So I'm going to start over here, and we're going to do by systematic trial. And over here, we are going to do by inspection. Now, the equation in our notes is 3d plus 5 equals 17. So we're going to use this exact same equation on both of these. So I'm just going to set that up, and we're going to look at what the differences are. Now, when I am solving this by systematic trial, basically this is what I also call intelligent guess and check. So we are going to pick a value that we think might be the correct answer for D, and then we are going to plug it in and verify and see if it works. So I might start with D equals 2. So what I'm going to do is I'm going to replace that D with a 2. And I'm going to solve. So I need to use BEDMAS or order of operations. So 3 times 2 is 6 plus 5 equals 17. So 11 doesn't equal 17, so that means that 2 is not quite large enough. So maybe I will try 5, because I know I need to get up a decent amount. So I will try 5. So I'm going to plug it in just like I did the first time. So 15 plus 5 equals 17. Well, 20 is not equal to 17, so we're not there quite yet. So it has to be bigger than 2, but smaller than 5. And the other thing I look at this is 11 is 6 away from 17, but 20 is only 3 away. So I'm going to choose a number that's closer to 5 than it is to 2. Now, this is something that comes with practice as to guessing what we might choose. So I'm going to choose 4 because 4 is closer to 5 than it is to 2. And when I do that, 3 times 4 is 12. Plus 5 equals 17. 12 plus 5 is 17. So that means that my answer to this equation is D is equal to 4. Now, when we look at inspection, it is a little bit different. So we are going to kind of play a little bit with the numbers differently. Now, inspection is something that is good if you have really good number sense and you can sort of see a pattern that jumps out at you right away. So I'm going to look at this 3D initially. And when I look at that, I'm going to look for things that I can multiply by 3 that get me semi-close to 17. So I might say that, well, 3 times 4 is 12, and 3 times 5 is 15. That's still a little bit low, so 3 times 6 is 18. So I've kind of gone on both sides of that. And then I'm going to look at this next part, this plus 5. And I'm going to say, okay, well, whatever that 3 times thing equaled, I need to add 5 and get 17. So I'm going to look at each one of these. And when I do that, I'm going to look and say, okay, well, if I start here and say 18, I can't add anything to that because I'm already over 17. So we know that that's not going to be the answer. 3 times 5, 15. I'm close to 17, but when I add 5, that gives me 20. And so these are kind of the things that we think about in our head. And so we know that that's not going to be the answer either. 3 times 4 gives me 12, and I know that when I add 5 to 12, I'm going to get 17. So this is another way that I can come up to that answer of D is equal to 4. Because I have multiplied by 4. Now, this is good with smaller numbers. Sometimes if we have bigger numbers, it becomes quite challenging just because our number facts maybe aren't as strong or we don't necessarily see the patterns in the same way. I'm going to do a couple of the examples from the notes as well. So I'm going to focus on the ones that are subtraction because when I was looking at our last check-in, for those of you that handed it in, I noticed that a lot of us were struggling with subtraction. So this example asks us to write an equation and then solve the equation. It does tell us different ways, so we are going to do the different ways that it asks. So the first question there, A, asks us, Ben takes Y caps from a group of 18 caps, and there are 12 caps left. How many did he take away? And it asks us to solve by inspection. So this is a really good example of a subtraction equation where we want to sit down and decide how do we write this equation. I always think about where did we start? So what number did we start with at the beginning before anything happened? So before Ben took caps away, we sat at 18 caps. And what we don't know is how many he took away, but we know that he took them away from 18 and that there are 12 left over by the time that we are done. So this is going to be our equation. If I want to solve by inspection, I need to ask myself, well, what number, when I take it away from 18, is going to give me 12? And I can do some guess and check, but we know that 18 minus 6 is going to give me 12. And so Y is going to be equal to 6. For B, it says that Ben put K caps in each of 6 piles. There are 108 caps altogether. How many caps did Ben put in each pile? So we want to know, in this case, what 6 times, however many caps he put in each pile, is equal to 108. So this one asks us to solve by systematic trial, so we're going to do a little bit of guessing. Now, when I start with my numbers, I always start with something that I can do fairly quickly in my head. So I might think of 10 first. And I'm not going to write this one down because when I look at 6 times 10 is 60, and I know I'm still pretty far off. So I might instead try 20 because I know that that's going to get me kind of close and it'll kind of help me gauge a little bit. So 6 times 20, if I'm going with k is equal to 20, is going to give me 120. Now I know that that's too large, so I need to do something that's going to get me another close number. So I might say k is equal to 15. And when I do 6 times 15, I get 90. So I'm kind of framing this a little bit. Now I can choose 17, 16, or 18. I would say that this is closer to 120 is closer than 90 was, but it was still pretty far off. So I might choose 18. Although if you choose something else when you are doing your systematic trial, that is totally fine. And I get 108. So that means that k is equal to 18. Now, I'm going to skip over C, and I'm just going to work on D because D is another subtraction question. But it is a little bit more complicated. So it says Ben combines P groups of caps into one large group. Then he takes away 7. And when he's done, there are 49 caps left. So I need to think about that. 4 caps in P number of groups. So I know that I have 4 caps in each one of those groups that I have. So that gives me 4P. And once I have all of those caps, Ben's going to take 7 away. So when we're looking at where did we start, we started with this number. We started with the caps in the groups, and then he took them away. And then we are left with 49. Now, this one asks us to solve by systematic trial, so we're going to do a little bit of guessing. I'm going to look at this 4P, and I'm going to try and guess, something that I think will be close. So I know I'm multiplying it by 4 first. So I might start with, let's try 10. So let's say P is equal to 10. So 4 times 10 minus 7 is 40 minus 7, which is 33. That's a little bit too low, but it is a really good starting spot because we know that 33 and 49 are relatively close. I might jump up to 12, let's say. Because I know I'm close, but I'm a little bit far away still. So 4 times 12 minus 7, that's 48. And I already know when I'm here, if I'm at 48 and I need to be subtracting 7, I'm not quite there yet. So I'm still a fair amount away, but I went up here 8, and I need to go up another 8. So when I look at this, I went from 10 to 12, and that moved me 8, and I need to do it another 8. So I might do P equals 14. So sometimes if you look at the patterns of what you're doing, oh, I'm writing that backwards, or wrong. Sometimes if you look at the patterns of what we're doing, it helps us as we work through. And that's kind of the trick when we're doing these types of equations, because it helps us guide how much more do I have to go. And so we're really using our estimating skills from previous units as to how we're going to get where we need to go. So here 49 is equal to 49. So that means that P is going to be equal to 14. So there is that other question on there that you guys can read through. I have some practice questions for you. Please try them. I know some of them will be frustrating. By solving by trial and error or systematic trial and inspection can be challenging if our number facts are not super strong. So know that things that'll help you is if you have a multiplication table handy, if you have a calculator to quickly do some quick calculations. Those are really good tools in this section that'll help you as you move through this to decide and see what you're going to need, and help you with gaining that understanding of maybe what number should I try next.